Hey everyone, my name is Matt Kosevec, CEO and co-founder of DataForge, and today we're going to be talking about how to build better data platforms using functional data transformations. One of the big problems today with building data platforms is that although there's a lot of great ways to develop them initially, as they are added to, augmented, modified over time, they oftentimes devolve into what we like to call spaghetti code because developer teams never have time to open up the monolith, figure out all the different problems that are inside of it, or even just what was built before, how to change it, how to update it to include new data elements, data pipelines, data transformations to what's already been built. And this problem is fundamental to the way developers build the code and structure it. What DataForge provides is a functional code approach rather than procedural scripting to help teams build and manage their data pipelines. There are three major features that make DataForge scalable and help teams manage this complexity over time. First one being reusable transformation code blocks. These are the functional snippets that help developers break down their code into smaller bits and bytes, break up the monolith, and help them make their code more composable, extensible, and reusable without having to copy paste code across all these different scripts and manage each bit of logic in one place and one place only. The next one is orchestration. With the functional code approaches, we found some great ways to automate a large portion of the traditional orchestration that is required in order to get data pipelines to run in the right order, both in the happy path and on the one-offs for backfill and other things like that. This is done through computer science concepts such as dependency injection and inversion of control, where we're relying on the way that the functions point to each other rather than manually defined directed analytic graphs or other approaches to specify manually, developers specifying manually how and what way the different scripts should point to each other or in what order they should run in order for things to process correctly and to be run efficiently, both with infrastructure and from a code perspective. Lastly, no good data platform, especially one that gets to the thousands or tens of thousands of code lines, should go without an observability repository. This observability takes a unique approach. So while DataForge is a code-first language and a code-first platform and a code-first library, one unique thing is that it is backed by a Postgres database. So all the code that you write, build, and manage, when you compile it and then ultimately deploy it to our cloud product, that is stored in a database that makes your code searchable with SQL queries, as well as look at column level lineage and many other powerful features to combine it with your processing history to help you and your team understand not only what is built, deployed, and compiled, but how it was run against the live data in your system. Two different sides of the coin. With DataForge, we have our core open source platform. This one is relatively straightforward. It operates on raw data that has already been landed within your data lakehouse or warehouse. That data then is fed through the functional code transformation structures, which compile to SQL. That SQL is then executed against the data warehouse and lakehouse to then produce the target data sets. DataForge Core not only does the transformations, but manages the tables for you so that new DDL scripts and those types of things are not having to be managed manually. It is handled as part of your code definition within the DataForge Core framework. DataForge Cloud takes this to an enterprise level and brings the entire data supply chain under its roof and into its framework. Therefore, it covers everything from ingestion into the raw data landing zone, which then there's a change data capture process because DataForge Cloud also handles incremental loads. DataForge Core is truncate reload only, which when you're thinking about cost efficiencies and large data and scale out architectures, DataForge Cloud has a number of services there to help automate and simplify the infrastructure management. And then as you can see, after the data is fed through this incremental loading process, it is then leveraging DataForge Core, which is the exact same framework for functional transformation code that the open source product uses, which then augments and transforms that code to then ultimately land it in its transformed and merged state. Again, specifically merged because it integrates this change data capture process, And then finally, DataForge Cloud takes it a step further and allows you to then publish that data to an external location outside of your lakehouse or warehouse. So for example, today DataForge supports Databricks for its core processing, and DataForge Core supports compiling code to SQL that is executable within Databricks. However, DataForge Cloud provides services that you can then publish your transformed data directly to Snowflake, or you can then take a copy of it and publish it to external files or Kafka or other services that are available outside of the Databricks platform. Finally, DataForge Cloud has a number of infrastructure services that help to simplify the management and automate the cluster management and all these different complex things that oftentimes data engineers need to deal with, and help teams do that without a lot of expertise, and using the most cost-effective underlying infrastructure possible to help teams be as cost-effective when they're processing large volumes of data. Next up, we're going to talk about our open source product and dig into some code so that we can get an overview of seeing what the functional code framework looks like. After that, we're going to open up the commercial UI to see what it looks like in our web-based user interface. And then finally, we'll wrap it up with a few more concepts and some case studies. All right, enough PowerPoints. Let's dig into some code. So first, we're just talk about the folder structure. We have three concepts here: outputs, sources, and relations that we need to talk about. Sources are going to be where your data is coming from, as well as the large majority of your functional transformations. Relations are going to be connections between sources. For those of you familiar with SQL, it's going to be a logical join condition with some extra flavor and structure around it. And then finally, outputs. This is going to define your final target location where you're going to store the results of your functional transforms, as well as do some non-functional stuff such as aggregations to new grains, filters, and things essentially changing the number of rows you're working with rather than just doing calculations on the rows that you already have set up within your source data sets. Let's look at a pretty comprehensive example here that has different types of transformations on it. Everything within DataForge Core, which is what we're looking at here, is YAML based. This is the easiest way for people to work with, but we've also tried to make the syntax relatively SQL-like so that it's easy for developers who are familiar with working with SQL to configure and get onboarded onto the code structure. At the top here, source name, this is just a metadata name for you to use to reference this group of code. Source table, this is going to be where you're pulling the data from in order to process and transform it using these functions and lines of code. And then finally, where are we going to take the result of these functions and transforms and store the end table in. Raw attributes, these are all of the columns you're going to pass through. So you can think of this as the select portion of a SQL statement, but you're not going to be doing any actual transformation on it. You're just saying, hey, here's the columns I want to get from samples TPCH line item, and I'd like to store the exact same columns as is in enriched line item for reference or for other reasons downstream. Next up, we're going to grab rules. This is the meat and potatoes of how you do transformations within DataForge Core. What you can see is we have a lightweight syntax. Anything that has this little bracket, this is what we call a source container. This references where you're getting data from. In the most basic example, we use the moniker this, which references any one of the raw attributes or upstream rules that are contained within this file. So you can see we're taking three columns: extended price, tax, and discount, doing a calculation, and then storing the result in a variable or a function result called net price int. This actually materializes into a new column post-pended to the columns that you see here on raw attributes. Now that we have this new column or this functional variable, we can then use it downstream in another expression or another function. So as you can see, we then took a combination of return flag and net price int to create then a new column or a new result called net price no returns. This is the way that you're able to break down what would typically require a common table expression or a with statement in SQL into much smaller code snippets that then are reusable and referenceable across the entire project. Let's get to something a little more complicated where we're going to reference data that is not on this particular source, we're going to reference data from another table or another source that we've defined. So jumping over to the customers file here, you can see there are no rules defined, just some raw attributes. However, one of the columns available to us is the name column. If we go back to the line item column, you can see with a basic rule, we're able to take the column from customer. You can see this source container references the source name in the customer file, and then we're going to grab the CNAME field from that source. How are we able to go grab data from another table? We're able to do that by traversing our relations. Traversing means jumping from table to table and doing that via join conditions. So going over to our relations file, you can see this is a global file across all of your sources that then defines your data model and how all the different tables are connected to each other. So if we think about how to get from line item to customer that rule example showed us, first we need to go to orders, then from orders to customer. And we use this join condition first on order key, and then this join condition second on customer key in order to make those two jumps. Because according to this data model, there's only one way to get from line item to customer, we're able to reference it directly without having to specify the number of jumps we need to make between these two different sources. However, if we do have the situation where there are multiple paths between two different sources, this is the syntax where you have to essentially spell out the different relation jumps that you need to make in order to go and retrieve that data. Else the compiler will yell at you, tell you, hey, I'm not really sure, exactly how you want to traverse these relations and what exact join conditions should be used in order to retrieve the n.name from the nations table. Moving down to something a little more complicated, we're then going to be blending two different sources together, right? So we have net price int, which takes a result from one of our functions here. And then we have a part supplier. We're going to grab a column from part supplier. Again, because there's only one path between line item and part supplier, we can use the shorthand syntax here. And you can see here in part supplier, this is a very simple raw attribute, so nothing too complicated here. But you can intermix the columns that are either created by functions and rules or raw attributes interchangeably. Our final example, and one of the more complicated ones, that just shows how once you create a function, once you create a new column using this syntax, it is just as good as any other column or raw attribute. You can actually leverage the result of a function in a relation. So in this case, between the line item table and the part supplier table, we actually have a compound key. And so here we have this compound key that we're just going to concat the part key and the supplier key. And then if I go over to the part supplier source, you can see we wrote a rule here that does the same thing, concats the part key with the supplier key using the same syntax. And then within our relations file, you can see where we then leveraged these results, the part supplier key and the PSP key. This then is defined as a relation between the two of them. One also nice to know thing is you don't need to write these rules necessarily in order, so long as they all are referenced and compiled correctly. The order of your rule definition isn't important. Finally, just highlighting that any available functions in Spark SQL, there's a long list of them, a lot of them very powerful, or your own custom UDF that you would define and send to the Spark cluster, you can leverage transparently within the code here, because under the hood, once you've compiled all this, it turns into executable SQL. You'll get one file per source, one file per output, and then you'll get one large file that will run all of the different queries in order to produce the final target data set. With that, it's a basic overview of the DataForge Core product. We will cover outputs in a follow-up video, and next up we're going to talk about the commercial product. All right, now that we have looked at the open source product, let's take a look at DataForge Cloud, which is our web-based user interface for the same framework, but with all of those extended features to take the data supply chain all the way from the source system to even reverse ETL or publishing to a target. There are many, many other features, as you can see here on the left. Before we just had sources and outputs and relations. Now we have a laundry list of additional features, documentation, support, many, many other things to help with both the development, operating, running, management, infrastructure of your entire data platform across every consideration imaginable, and to help you build and maintain and extend it over time. We have the same exact set of sources here in the graphical user interface here. We're going to look at TPCH line item the same way. One thing I do want to note though is that this is now a operational user interface as well. So we have the status, these green checkboxes. They indicate that all of these data sets have processed correctly. So there's a large amount of logging and other things that the cloud platform helps with as well. So let's click in here. You'll see we've loaded this data set 4 times. This is again another kind of operational platform for users to manage and monitor as things are processing through. And the most recent one, because this data set's not changing, has all of the effective records. Let's look at the rules. This is the same rules that we were looking at in the open source product. However, now there's a nice interface here for people to work with. As you can see, we have, again, extra metadata available, as well as this nice expression box. This expression box has a lot of features that allows developers to quickly and easily write rules and ensure that they're going to be correct real time versus having to type a bunch of things and then compile them, hope they work, fix the next issue, so on and so forth. So let's look at an example of that. So if I just delete this part of the statement, I can do this open bracket this. It also lists every other source that is available via relations connected to this one that I can then also go reference data from. Let's look though at this example. I believe this was a return flag. Got autocomplete here. And you can see it through this giant red text at me because this statement, this SQL statement as typed, would not compile. It would have a data type mismatch problems here because we're trying to compare a Boolean to an int is true. And you'll see now it's giving you an example of, hey, we want to get the result type, and it automatically is determining that the result type should be an int. However, you can override to other things here. And then finally, another thing, again, I talked about in the introduction on the PowerPoints about incremental loads and automated orchestration. This recalculation mode is a very important part of determining how and what way to work with data sets. We'll cover it in another rule that we're going to look at shortly. When we click save, it checks everything across the entire platform. Does this rule pointing to other things or is referenced elsewhere? We'll make sure it's going to be correct. In this case, we were all good there, so it's saved correctly. Let's look at an example that then references data from another source. Here you can see we actually did a concat. This is a rule that was not in the open source example, but this is one that we have now as an example in the commercial side. So we have the reference to the name column twice. And rather than having that long form syntax where we had to type out all the different paths between 2 different sources, you can see the system will automatically determine the shortest path, and then just with some simple drop downs, you can determine what traversals you need to do across the relations in order to get to this target data set. The other thing I'm now going to come back to is recalculation mode. The difference between snapshot and keep current is whenever the data set that is being referenced here, in this case, the nation source, when that data set is updated, let's say there's a master data source, or again, in this case, it's a reference source. Let's say that, a name alias was, updated from US to USA. If we wanted this rule to then reflect that update, we would check this keep current box, and then the system would generate a new job to process this rule, this expression, and all downstream rules for it when that other source is updated and calculated. So this is, again, on a rule by rule basis, how engineers are able to determine how and what way everything is orchestrated without having to manually define the exact order of operation for each package or each subscript that is being developed. Once you have everything configured, then the platform is responsible for running and executing things in the correct order based off of each one of these configurations. Going to now quickly look at bringing in a new data set very quickly. So a lot of the code and a lot of the typing required in the open source product is automated within the DataForge Cloud platform. Let's go to a new project that's completely empty. So here again, each one of these projects is essentially its own code base that can be worked through and referenced. Let's grab the one on demo video. It's currently empty. So you see we have no sources, no outputs. There's no code currently in this project. Let's start from scratch and go grab some data from an example data set. In this case, because we're in DataForge Cloud, we're able to get data from an external place, such as a SQL server. So when I click on connections, this is all external connections that are then able to have data pushed from or push data to. So in this case, we have a source connection. We're going to get data from this database. It's a SQL server. Here's a few credentials. And this connection metadata then is going to allow us to look at every single table that is available within the database that we're going to pull data from. Let's go to the sales schema. Let's look at sales order detail, and then we're going to hit some magic buttons. One thing you'll notice is we're also tracking the primary and reference tables and foreign keys. This allows us to automate even more of the code generation when we're able to ingest this data and scan the metadata for it. So now that I check this, I'm going to click some buttons here that say add reference tables recursively. This is now going to go up the hierarchy, get all the different reference tables that I may want to use in my rules and grab those as well. And then I'm going to click create sources to generate all the different parameters, all the different baseline code in order to begin processing these many sources that are now checkboxed. Now that we've began generating all the code, you can see now we went from a blank project to now we have 11 sources that have all been automatically configured. If I go into sales order detail, you'll see we already have all of the raw schema. These were things that were previously forced to be hand typed. We also have a large number of settings pre-populated. This is another thing that's in the commercial in DataForge Cloud only. Here, you're going to be specifying, again, things such as infrastructure parameters, data retention policies, as well as, again, more advanced incremental load and refresh. So again, here, we're able to specify a compound key. This is going to be the way that data refresh is tracked through the entire end-to-end set of processes to move the data from the source system all the way to its targets. You can see there are a number of other options here pre-configured, as well as a custom option if something is outside of the standard options. And then finally, once we are beginning to bring the data in, you'll see it began kicking off a new cluster. There's an entire part of the platform around Databricks cluster management and helping developers simplify how they work and interoperate with the Databricks platform, which helps to power the back end of DataForge. Now that we have all of these launching, they will begin processing and moving data throughout the different pipelines. I have one ready to go for this example. Here, if we go to sales order detail, we can see all the different intermediary processing steps that moved it through the processing chain, index logging, debugging, so on and so forth, to help developers quickly and easily identify what's going on in the system, both from a rules and relations perspective. Again, here we have all of the open DataForge Core code within the UI intertwined and fully transparent with the actual operational happenings within the platform as well. So we got the data was brought in, change data capture was against it. We ran enrichment and refresh, which applied the rules and relations to the data sets, merged the data into a target data. And then in this case, we actually have some outputs configured as well. Lastly, there's some data profiling that happens as well if configured. And that makes it really easy for developers to quickly understand what the different raw data looks like without having to do a lot of different exploratory queries. So that they understand what types of rules or what types of relations they need to develop and iterate on effectively. The last thing is, at any point as you're developing or as you're working, let's go back to the demo, this was the same project as the open source product that we walked through. Let's look at one more feature, which is the lineage visualization. So at any point, you're able to jump in here and at any column, across any point, whether it's both a rule here or a raw schema or an output column, which we haven't covered, you're able to jump in and create a new graph. So let's look at where is the tax column used and what does it map to? So let's go through here at destination recursive. You can see a graph was created here to show all the different target data sets that this one column is used in. So it's used in a set of rules. We got the net price int, we got the revenue calculation, we got the revenue net supply cost, and you can see that these two rules here, in fact, don't go anywhere. So maybe we should delete these. But you can see revenue is used many places, net price int is used many places, and tax is actually used directly as part of different mappings to different outputs. Everything on the right-hand side is representing a target output column. These are typically, again, going to be for a target report. In this case, it's a feature that we're developing for an ML training model. This one is for a reporting environment, so on and so forth. This makes it really easy, again, at any point to understand where and how different elements are used and how you can identify quickly where potentially a problem is or what went into a certain calculation. For example, let's now navigate through revenue here. Let's isolate on revenue, and then let's add origin recursive. And you can see here's the way that revenue is calculated. Revenue is mapped to this revenue calculation, which is net price int, which uses discount, extended price, and tax. Now we can see all the different columns from all the different sources that are created or used in order to calculate this target revenue column in this reporting data set. With that, we'll wrap up the demo. This is, again, the cloud product. We've covered maybe 10% of all the different features, but hopefully enough for you to get a feel of the capabilities and how it can help your teams build better data platforms using this functional code framework to iterate and expand and evolve your platform over time. All right, last section. This is just going to overview kind of the value statements and what this actually means for people who leverage DataForge. And this is just a quick summary we've seen with a number of our customers is that for the initial build, oftentimes they can reduce their overall developer time and timeframes and time to value by over 60%. This is primarily done by shortening developer life cycles, by reducing the number of tool integrations required, and as well as the infrastructure deployment. We didn't cover a lot of it as part of this discussion in the demo today, but there's a large number of Terraform scripts and other tools and technologies we provide with our product to help teams quickly and easily stand up a new cloud environment, integrate with an existing DataForge workspace, and get things moving much more quickly than having to spin it yourself or to have to integrate external tools in addition to your transformation code framework. Finally, we also didn't cover a number of features that help with the DevOps process, Git integration, promoting between environments, working through DevSecOps, many other things that go through the cycles to help cut down all the different dynamics. And then the final piece here is design. With DataForge, you're choosing a code framework, you're choosing a storage architecture, you're choosing all the different kind of intermediary steps of where the data is landed. Your medallion architecture is built into the platform so that you as a developer or you as an architect are not having to worry about the minutia of where are we going to store this intermediary data layer or that intermediate data layer. You can focus fully on the business requirements, the transformations needed to consolidate the information, to transform it, to cleanse it, and to publish fantastic data sets to your target audience. But as we mentioned, the real benefits of DataForge, which we'll talk about in the case study, is adding stuff to an existing platform. So again, oftentimes the design and development, this is where you're spending so much time trying to figure out where does this new thing fit into the existing platform? How and what do I need to open up and look at in order to understand what is even happening in the existing structures such that I can then make a hypothesis of where this could fit in, or just giving up on all of that and just tacking on a standalone solution or building a parallel path to what's already developed to prevent the need for regression testing or data backfill. These, again, if you go down the kind of best practice but painful path of integrating and involving yourself in stuff that's already developed, you then do have to go back to make sure you didn't blow up stuff that is already in production and working well. And then what do you need to rerun or execute your pipelines manually to ensure that not only are the new features and new data elements populated correctly, but that as part of those reruns, you're not affecting or causing issues with existing data sets. With DataForge and the way that we structure the code, the way that we require developers to think about their relational algebra and how they fit it within the platform and framework eliminates a huge portion of it, specifically regression testing. And then data backfill is handled automatically by the orchestration automation and the functional relationships between the different rules. And again, because we have the column level lineage, we have the observability platform, identifying where and how things are happening is very easy and very straightforward. And then, of course, being able to jump off an existing functional chain is super straightforward. There's no decision-making process on how and what way to integrate. There's only one path to take, and it is the path that follows the existing framework so that developers can be more consistent across the entire platform. So again, this is where you see the huge time savings. This can be even more if things have gotten really out of hand and you're in the kind of 10,000 plus rules and relations kind of structure. Speaking of kind of large platforms and big deployments, one of our favorite customers here is ServiceLogic. They were able to deploy a large number of ERP integrations from their portfolio companies into a consolidated financial and operational reporting environment, which has now evolved into more advanced use cases than just reporting. But this case study covers their first pilot project, which integrated 18 systems in 8 months. They now are able to do that with a new company that they acquire. They're able to execute a new integration in just under 2 weeks. It's got over 1,100 data sources, 25,000 custom enrichment rules. And the amazing piece is that this is able to be maintained by a team of just 2 full-time employees. And this ability to scale out to this many data systems, and in fact, it's not on this page, but they have over 60 different systems integrated today. That is, being able to maintain that with just 2 full-time employees is truly the differentiation here. Not only are they able to maintain it, but they're able to continue to expand, continue to add to it over time with a straightforward process, with a great run book and a great set of team processes. They're able to continue to expand and not have their data platform be a burden on their ability to strategically acquire new companies and to meet their goals for growth as they continue to roll up different HVAC companies as part of their solution. This has been a great success story. And with that, we're going to wrap it up. Thank you so much for walking through the entire demo with me. Really excited to get more people involved in the open source community. Please check us out on GitHub. And then, of course, go to our website, www.dataforgelabs.com, to schedule your own demo. We love to engage with and talk to teams, hear more about what their challenges are today, and ensure that whatever we're developing next is going to address what they're hitting today and where they're going to be tomorrow. Thank you so much. Have a great day.